This is the video presentation for the British Library Systems Engineering Project. We will be outlining the aims of this system, as well as the research and development of our proof of concept. The main aim of our project is to be able to classify images from the British Library's dataset in order to enable searching and retrieving images by their content. We are hoping to achieve this by using machine learning techniques to automatically assign tags to images based on their appearance using information learned from known data. The dataset itself comes from a large number of books ranging from the 16th to the 20th century that were scanned in since there was no existing digital copy. After scanning the books in, the text was automatically extracted and any unknown regions were also extracted. In fact, many of these unknown regions are actually images in the book, however their actual content is not known. The problem comes from the fact that this set of images is very large, containing over 1 million images. It would take a long time for these to be tagged with appropriate keywords by hand, and any further books that are scanned would also need somebody to tag them individually. Currently, the images are in the public domain and uploaded to the photo sharing website Flickr, where users can tag images. This gives us a good place to start in terms of the type of tags people are interested in. However, there are a lot of images, and the Flickr tags are only a start. The requirements for our project are fairly straightforward. Firstly, we must have a set of images, probably a subset of the British Library dataset, with correct known tags. This can be done manually and will be used as the basis of an automatic image tagging method, our second main requirement. Using the tags, it must then be possible to find individual images according to their tags, as well as being able to group together images with similar tags to enable their retrieval. Although the dataset is very large, from looking through it manually, it is clear to see a tendency towards certain types of images. Since the bulk of the images are from books published in the late 19th century, it isn't surprising that they have things in common. Something that is quite noticeable is that there are distinct categories that images can be separated into, even if they are quite broad. For instance, being able to detect whether an image is a photograph, a drawing, or something else entirely. One big separation in the dataset is between full-color images and black and white printed images. In fact, the majority of images appear to be printed in only black ink, rather than full-color paintings or photographs. This is an important distinction to make, as if we can successfully separate them, then we can do machine learning that takes advantage of the fact that all the images are grayscale, ignoring variations in color between images, as they are likely due to problems when scanning or issues unrelated to the image's content. For the machine learning aspect of our project, we looked at a number of different approaches available to us. Machine learning is an active but complex subject in computer science, but there are a number of implementations of machine learning algorithms that we can use. Some of these are more accessible or useful than others. We will outline the three main approaches that we found during the research. As well as this, we also looked at the Azure Machine Learning Studio, which intends to offer a full suite of machine learning algorithms in a visual interface, but it didn't quite seem suitable for our project. One approach we looked at is using a service called COMP2013, which has an app but also a public API. COMP2013 allows you to retrieve tags for images simply by sending it a photo, with no extra parameters. Hence, it is very straightforward to use and easy to integrate. However, from our experience testing, although the results were very promising for a lot of the images in the British Library dataset, it also struggled with a large number of them, especially diagrams, graphs, and illustrations not representing real-world objects or scenes. It would probably not be useful as the main approach for our project, but could be helpful in conjunction with something else. Neural networks are an active area of research that is currently producing some of the most compelling results in machine learning, and so it was clear that we should investigate using them for our project. However, due to the algorithms being complicated to use as they are, we don't think they would be appropriate for us to use outside an integrated application due to the expertise needed in picking the right algorithm and adjusting the parameters appropriately. Finally, we looked at an application called Weka, which is a collection of machine learning algorithms. This is helpful as it means it's straightforward to apply a range of different algorithms on the same data and compare the results to see which is most effective. Due to its flexibility and ease of use, this will be the primary approach that we use for our project.
So as part of the process, we had to cover experiments in order to finalize the prototype. We made 3 initial prototypes and evaluated each of them separately with the help of some users. Based on each prototype's positive and negative feedback, we made a final prototype for the user interface. Each row in this slide is a different initial prototype. Everybody in our team created one design prototype and tested it with users so that we knew which features to include and which ones to exclude for the final design. We then took the best features and included them into the final prototype. One useful feature in the first prototype allows users to find similar images to a specific one. This is something we ended up incorporating into our final design. Another useful feature, which was in the second prototype, is the familiarity of the Google image search pages, which we also incorporated into the final design. One strength from the two initial prototypes is the similarity it had with the Google Images interface. This is useful because the user is already familiar with this interface, so they can navigate quite easily. Another strength that we took from the initial prototypes is how easy it was for users to navigate between the pages. Each feature was clear to the user, and so users knew exactly what to do whilst on certain pages. An issue, however, with the first prototype is that users were presented with only a limited number of tags. This is an issue because users may want to view images that have different tags. Another issue is that users do not have much scope for preference and change because not many options were available for the user. Finally, we combined the strengths of the initial prototypes and created a new design one. This new design prototype was not evaluated yet though, so we applied heuristic evaluation on it. This involved going through the design and identifying key usability problems against a list of 10 heuristics. This is the table for the heuristic evaluation carried out on the prototype in order to generate the final design prototype. The final prototype, which is here, used the strengths and avoided the issues so that it gives the best user experience.
This is the web interface of the British Library application that can be accessed from all major browsers such as Chrome, Safari, and IE. The purpose of this interface is to provide a visual aid for researchers to look for tagged images from the British Library collection. This application is how the interface would look like and how it functions when it's finished. In this demo, I'm going to show you how everything works, as well as the possible use cases of the application. This is the home page, and below is the search box. This is where we query the images that we would like to see. So for this case, let's look for ancient animals. And to search for this image, click the search button on the right. So here are the results of the images when we queried ancient animals. For each results, we have details and similar images. Details contain all the tags available, and the button below, as the name suggests, gives you the similar images. Let's go to the details of the images. Here is the image details page where you can see the enlarged picture that you have selected and the list of all the tags that are associated with it. The tag categories classifies the tag based on the categories available in there. As you can see, the location tags correspond to places such as Europe, England, and Portugal, and so on. Let's go back to the results. Let's find the similar images for this one. As you can see, here are the images related to the images that we have selected. On the right, we have the most similar images. And at the bottom, we see some other kind of similar images, such as the images from the similar book and similar categories. So I will now discuss the achievements. So here are our achievements so far. We have finalized the user interface for the prototype application, and we also have successfully researched the variety of technology and APIs that we can use in our project and selected the best out of them to build our application. The main feature of our final prototype will be the search function that finds tagged images as well as all the individual image and results page. It has a simple and familiar search engine interface that many people are familiar with, and UI entities to help user navigate through the application. We have chosen to use Node.js for the following reasons. It is high performance, low-level web framework that utilizes Chrome's V8 engine and can be used to make small to large size applications that can be integrated easily to legacy systems. It's lightweight and easy to set up. Node.js is ideal in data-intensive real-time application due to its high performance, such as our application. For the front end, we will use Bootstrap and jQuery. It is a very popular front-end framework that provides sleek and clean-look interface. And jQuery, which is the dependency of Bootstrap, helps us manage the inner side of the front-end interface and provides many UI functionalities. For version control, we use Git as the system and GitHub as the platform to host our source code. We use Git to manage our source code and also track the changes made to it. We also use it as the backup strategy in case something bad happened to our source code and we need to revert it back to the previous version. GitHub offers a platform of collaboration where contributors can collaborate even when they are not in the same place, thus giving them the flexibility to work anywhere.
In order to finish the British Library project, implementation needs to begin as soon as possible. So the two main requirements that we have in this project are creating the image searching feature and creating the image tagging feature. We have set deadlines in order to achieve this goal. The deadline we have set for locating the image base is on the 9th of January. This is crucial as we need the images in this project. You can see the deadlines in this Gantt chart below. We have also set the deadlines for creating the image searching feature, which is on the 7th of February, and the deadline for the image tagging feature, which is on the 30th of February. We also plan on testing throughout the whole process because we are doing test-driven development. So whenever a new feature needs to be added, tests for this feature will be created. This ensures that our application has the least number of bugs as possible. We plan on finishing the implementation and the whole project, including testing, by the 11th of April.